Good day! Welcome to another topic entitled Database Systems. Again, this is Dr. Mary Jane Samonte from Mapua University, Philippines. Organizations use data to keep track of their day-to-day operations. Such data is used to generate information, which in turn is the basis for good decisions. Data is likely to be managed most efficiently when it is stored in a database. In this chapter, you will learn what a database is, what it does, and why it yields better results than other data management methods. You will also learn about various types of databases and why databases design is so important. So, let's begin!
Learning objectives. At the end of this lesson, the students are expected to enumerate the types of databases and identify the database functions.
So why do we need databases? In today's world, data is ubiquitous. From birth to death, we generate and consume data. Also, it is pervasive. The trail of data starts with the birth certificate and continues all the way to a death certificate and beyond. Databases make data persistent and shareable in a secure way. Data is not only ubiquitous and pervasive, it is also essential for organizations to survive and prosper. All businesses have to keep this type of data and much more. At the heart of all these systems are the collection, storage, aggregation, manipulation, dissemination, and management of data. Virtually, all modern business systems rely on databases. Therefore, a good understanding of how these structures are created and their proper use is vital. To understand what drives database design, you must understand the difference between data and information. Data consists of raw facts. The word raw indicates that the facts have not yet been processed to reveal their meaning. Information is the result of processing raw data to reveal its meaning. Data processing can be as simple as organizing data to reveal patterns or as complex as making forecasts or drawing inferences using statistical modeling. To reveal meaning, information requires context. For example, an average temperature reading of 105 degrees does not mean much unless you also know its context. Is this reading in degrees Fahrenheit or Celsius? Is this a machine temperature, a body temperature, or an outside air temperature? Information can be used as the foundation for decision making. Efficient data management typically requires the use of a computer database. A database is a shared, integrated computer structure that stores a collection of the following: end-user data, it is raw facts of interest to the end user; metadata, or data about data, through which the end-user data is integrated and managed. The metadata describes the data characteristics and the set of relationships that links the data found within the database, which presents a more complete picture of the data in the database itself. For example, the metadata component stores information such as the name of each data element, the type of values, and whether the data element can be left empty. Given these characteristics of metadata, it is a database that is described as a collection of self-describing data. A database management system, or DBMS, is a collection of programs that manages the database structure and controls access to the data stored in the database. In a sense, a database resembles a very well-organized electronic filing cabinet in which powerful software helps manage the cabinet's contents. The DBMS serves as the intermediary between the user and the database. The database structure itself is stored as a collection of files, and the only way to access the data in those files is through the DBMS. It enables data to be shared, presents the end user with an integrated view of data, provides more efficient and effective data management, and improves sharing, security, integration, access, decision-making, productivity, and many more. Figure 1.4 emphasizes the point that the DBMS presents the end user or application program with a single, integrated view of the data in the database. The DBMS receives all application requests and translates them into the complex operations required to fulfill those requests. The DBMS hides much of the database's internal complexity from the application programs and users. The application program might be written by a programmer using a programming language. It might be created through a DBMS utility program. Having a DBMS between the end user's application and the database offers some important advantages. First, the DBMS enables the data in the DBMS to be shared among multiple applications or users. Second, the DBMS integrates the many different users' views of the data into a single, all-encompassing data repository. A DBMS can be used to build many different types of databases. Each database stores a particular collection of data and is used for a specific purpose. The number of users determines whether the database is classified as a single user or multi-user. A single-user database supports only one user at a time. If user A is using the database, users B and C must wait until user A is done. A single-user database that runs on a personal computer is called a desktop database. In contrast, a multi-user database supports multiple users at the same time. When the multi-user database supports a relatively small number of users, can be fewer than 50, or a specific department within an organization, it is called a workgroup database. When the database is used by the entire organization and supports many users, which is more than 50, this is across many departments, the database is known as an enterprise database. Location might also be used to classify the database. For example, a database that supports data located at a single site is called a centralized database. A database that supports data distributed across several different sites is called a distributed database. Both centralized and decentralized databases require a well-defined infrastructure to implement and operate the database. Typically, the infrastructure is owned and maintained by the organization that creates and operates the database. But in recent years, the use of cloud databases has been growing in popularity. A cloud database is a database that is created and maintained using cloud data services such as Microsoft Azure or Amazon AWS. A popular way of classifying databases is according to the type of data stored in them. Using this criterion, databases are grouped into two categories: general purpose and discipline specific. General purpose databases contain a wide variety of data used in multiple disciplines. For example, a census database that contains general demographic data. Discipline-specific databases contain data focused in specific subject areas, like for academic or research purposes. The most popular way of classifying databases today is based on how they will be used and on the time sensitivity of the information gathered from them. For example, transactions such as product or service sales, payments, and supply purchases reflect critical day-to-day operations. Such transactions must be recorded accurately and immediately. A database that is designed primarily to support a company's day-to-day operations is classified as an operational database, also known as an online transaction processing or OLTP database, transactional database, or production database. An analytical database focuses primarily on storing historical data and business metrics used exclusively for tactical or strategic decision-making. Analytical databases allow the end user to perform advanced analysis of business data using sophisticated tools. Typically, analytical databases comprise two main components: a data warehouse and an online analytical processing front end. The data warehouse is a specialized database that stores data in a format optimized for decision support. Online Analytical Processing, or OLAP, is a set of tools that work together to provide an advanced data analysis environment for retrieving, processing, and modeling data from the data warehouse. In this recent time, this area of database application has grown in importance and usage to the point that it has evolved into its own discipline, business intelligence. The term business intelligence describes a comprehensive approach to capture and process business data with the purpose of generating information to support business decision-making. Databases can also be classified to reflect the degree to which the data is structured. Unstructured data is data that exists in its original state, in a format that does not lend itself to the processing that yields information. Structured data is the result of formatting unstructured data to facilitate storage, use, and generation of information. You apply structure or format based on the type of processing that you intend to perform on the data. For example, printed paper invoices can be scanned and saved in a graphic format as images for future retrieval and display. Most data, which is classified as semi-structured, have already been processed to some extent. If you look at a typical web page, they also use semi-structured and unstructured data. Unstructured and semi-structured data storage and management needs are being addressed through a new generation of databases known as XML. Extensible Markup Language is a special language used to represent and manipulate data elements in a textual format. An XML database supports the storage and management of semi-structured XML data. Why database design is important? Database design refers to the activities that focus on the design of the database structure that will be used to store and manage end-user data. Data is one of an organization's most valuable assets. Well-designed database facilitates data management and generates accurate and valuable information. Poorly designed database can cause difficult to trace errors that may lead to poor decision-making. A brief explanation of the evolution of file system data processing can be helpful in understanding the data access limitations that databases attempt to overcome. To be successful, an organization must develop systems for handling core business tasks. Manual file systems was accomplished through a system of file folders and filing cabinets. Generating reports from manual file systems was slow and cumbersome. Data processing specialist was hired to create a computer-based system that would track data and produce required reports. The user's desire for direct, hands-on access to data helped to fuel the adoption of personal computers for business use. File System Redux is a modern end-user productivity tools, includes spreadsheet programs such as Microsoft Excel. The description of computer files requires a specialized vocabulary. Table 1.2 will help you to understand subsequent discussions more easily. The term data is said to be raw facts. Data has little meaning unless it has been organized in some logical manner. Field, a character or group of characters that has a specific meaning. A field is used to define and store data. Record, a logically connected set of one or more fields that describes a person, place, or thing. Then file, a collection of related records. In Figure 1.9, each file in the system uses its own application program to store, retrieve, and modify data. Also, each file was owned by the individual or the department that commissioned its creation. The advent of computer files to store company data was significant. It not only established a landmark in the use of computer technologies, but also represented a huge step. The next slide will continue the discussion of fundamentals of database regarding the problems with file system data processing.